So in our game right now, when a player joins, they can immediately move. And we want to have a type of game which has a countdown, so it goes like 5, 4, 3, 2, 1, and then you can move. And at some point we want it as well to react to that, okay, we have reached the finish line. So either we can have one player that wins or multiple players that continue to the next round. But as a start, we're gonna at least be able to make sure that we can detect when a single player has reached the finish line. So let's start with opening up our Quantum project. So we're going to add a game state that controls what should happen in the game. So let's go under game logic, right click, add a new item, and it's going to be a game state, and it's a QTN file. And it's going to be an enum, so it can have different states. And either it can be in countdown, playing, or game over. So this controls what is happening in the game. So while the countdown is running, we are going to have this 5, 4, 3, 2, 1, and then we are going to change into playing. And once we have sort of reached the finish line, we are going to go into game over. All right, so let's save that. Then we are going to create another QTN file. So let's add new item, game session.qtn. And the game session will contain the game state, but also some other information that we want to, well, have about the game, and it should be accessible to all our different entities. So we will create a singleton for this. So it will be a singleton component game session. And it will contain our game state that we had, so that becomes accessible. But also we want to have our countdown. So we're going to do FP time until start. And let's just change the formatting here. So this will be a variable that has some type of value. Maybe it should be 5 or whatever we want to have in our game. So it will count down from this value until it reaches 0, and then it will flip the game state. So we could use this potentially for other things as well, like measuring the time, because that will be able to detect when the game has actually started and how long we've been playing. Then we are going to add a system that controls this. So let's add a new item and game session state system.cs, and it's going to use the same structure as our other systems. So let's just get rid of this and paste that in, and let's just clean up the code a bit. So it has an error here because we haven't implemented update, and we're going to add that, and as well as filter. So let's start with our filter first. So our filter is going to be our public entity ref entity, and then our game state game session that we created here, the QTN file, and you need to use the star because it's a pointer to the, and call it game session. And then we are going to actually just add a public on in it, so when it starts up, this fires off. And what we will just do is we're just gonna write quantum game session state system on in it, so we know that it's been actually called and is running, and we're not going to do anything except that. And then we are going to go for our update. So now at least those errors are gone, but we can see that we have an error here, highlighted game session. It doesn't know what it is, and we can fix that by just building it. Then it will detect the QTN file and prepare everything for us. So after a while it will disappear. Great. So in our update function, we are going to get our game state, and we do that through our game session here. So game session, and don't forget the star here, is equal to, and then we are using f unsafe get pointer singleton, and then provide our game session here. This will fetch our game session so that becomes accessible for us. And after that, let's just check that it actually is not null. In that case, we don't know what to do with it, but we're just going to return. And after we've done that, we can actually start to interact with our game session here. So what we want to have is our countdown. So we are going to actually use that countdown all the time. So let's get our game session and then our point to time until start, and we want to count this down. So we are going to do our game session time until start minus f.delta time. So our f.delta time is the delta time in seconds. So it will just for each time it updates, it's going to get a value here. So it's going to count down. All right. And after we have reached a certain point, we want the game to start. So when it is 0 or actually smaller than 1, then we're going to say that, okay, the game can start. So we're going to check if game session time until start is smaller than 1. And then we are going to say that, okay, as well, for this to be true, we need our game session state to be in countdown. So this will become true as long as our time until start is bigger than 1 and we are in countdown. What we will do then is we will shift our game session state to game state playing. And let's add it to our debug log as well. So Quantum game session state system countdown completed. So when we are reaching this point, the game can start. Then we need to adapt our movement system so it actually as well doesn't allow the player to move before the countdown is completed. So let's open our movement system, and in the update, before we actually get our input, let's get our game session here in the same way that we did before. And just to be sure, we're checking that it's not null. And then we are going to check our game state. So if the game state is not equal to playing, then we are returning. So in that case, we're not allowing the player to move and we're not executing any of this code. And yeah, I think we will leave it at that as a start at least. And then, of course, we need to add our system here. So on the system setup, we need as well to have new game session state system, end it. And then I think we are good to at least try this. So let's just build it and then switch back to Unity. Then we need to create an entity that can have our game session. So let's right click, go to Quantum, empty entity, and then under our component, entity components, press plus, and then we have game session. Time until start, so maybe we should have that as 5. And here we can see that, okay, we have our state here, countdown, playing, game over. And right now we can change this, we can set it to whatever we want, but actually we don't want this to be changeable. So we're going to add something on the Quantum side that makes sure that this actually gets hidden, but that's we'll do that later. So now let's just rename our entity here and call it game session entity, and then we'll create a prefab from it. Game session entity, there we go, and save, and now can try it. So I'm pressing the move button and nothing happens, And now it started to actually allow me to move because the countdown here is completed. So now we have our system up and running, but of course we want some type of indication on the screen, because otherwise players are gonna think your game is broken. So let's add that as well. So let's add a game object and UI, and we want it to have its own canvas. So let's start with a canvas, in game UI canvas, and then let's add a game object, and we are going to use a text mesh pro. So let's add that. Oh, we haven't imported it, so just import TMP essentials. Okay, so, and then let's add it again, UI text mesh pro. So then we have our text mesh pro here, and our UI canvas is this section here. And let's move it to our center position, and let's make it really big, 1920 and 1080, something like that. Oh, not really 1080, maybe 300. And let's add our text here, and we are going to center it, so it's going to be a countdown going like 5, 4, 3, etc. But let's just make it really big, like 280. And as well, let's say that our UI canvas here, and actually our canvas shouldn't have our text mesh pro. Hold on, let's remove that, and yeah, that's great. So, and then we will use our scaler here, scale with screen size, 1920, oh, 1920, 1080, and let's actually have a look how that looks. So in our game view we have it here, and let's just move it up a bit. Oh, too much. Actually, I usually have my game view on another screen, but while I'm recording I don't have that. Why don't I see my bounce? Oh, here we go. Alright, so that's our screen bounce, and let's move it down. So there we go. And we wanted maybe to say game over as well. So now at least it fits the screen. Game over. Yeah, awesome. But we're gonna start with just a countdown. And then as well, let's pretty it up a little bit, and let's use an outline, and let's add a thickness to it, something like that. So yeah, I think that looks okay. So now we have our 5, 4, 3, but it's not updating, so we need to write a script that handles it. So let's go into our scripts and create a in-game UI handler, and let's open that in Visual Studio. So let's add using TM Pro and Quantum, because we need to access some things in Quantum and we want to have access to our text variable. So add serialized field, text mesh pro GUI, and countdown text is going to be our text. And then we need to gain access to Quantum, and we are actually going to create a little helper script for this. So let's go under C# here, scripts, and add a new item, and we'll call it utils.cs. So it's going to be a script or another script, and actually I could have done it from a template, but yeah, it doesn't matter. And it's going to be a public static class utils, so we can access it everywhere, and then add a public static bool, try get quantum frame, and it's gonna give out a frame. So let's start with it being null, and then we are going to check if quantum is equal to the default is equal to null, then it's something is wrong and we can't access it. So let's return false in this case. And then we as well is going to check if default.game is null, then once again we will not be able to access the frame. And otherwise we are going to get our frames.predicted and say that this is the frame that we are actually going to use. And if this frame is equal to default, then we are going to return false. So if it's null for some reason, then we are going to return false. Otherwise we are happy and we are going to return true. So that will allow us to get a quantum frame. Actually we can say try get and then predicted quantum frame, but we can change that later on to be able to select what type of frame we're interested in. But for now, let's leave it as that. And yes, the formatting is okay. And then we are going to use our utils here. So let's check if we have gotten our quantum frame. Then we can try as well to get our singleton from it. Frame, try get singleton entity ref, and then add game session, and out is going to be a variable called entity, which we are checking if it is false. So if it is false, it means that we actually didn't get our singleton. So let's use our countdown text here to say that the game session singleton not found. Otherwise, and return. Otherwise, it's going to continue with our code. So let's get our game session. So var game session is equal to frame get singleton game session. So then our game session here will contain that. And let's get our time until start, and we are going to call it int countdown. And then we are getting our game session time until start, and we're casting it into an integer. Okay, so now we have that. We want to check what our state is. So switch game session state. That is our enum there. And if it is countdown, sorry, break. So if it is countdown, we are going to execute this code, and we are going to add our text here and say that our text is going to be countdown. All right. And if it has just turned into playing, then we are going to say that, okay, if it's playing and our countdown is equal to 0, then we are going to write go. So exactly when it is 0, for that period of that second, we're going to write go. And after it, we are actually going to say that, oh, sorry, that needs to be inside our break. There we go, break. If the countdown is 0 or smaller than 0, then we are not going to write anything. It's going to be blank. And then we have our last case. If our game session state is game over, then let's add game over to our text there. Okay, so let's save that and go back into Unity. So let's change our text here and just add countdown, or actually it's not countdown, it's game state. And then let's add our script to there we go, and assign it. So now if we run it, it should hopefully start to update. 4, 3, 2, 1, go. and now I can actually go. So yeah, now we have our countdown. So the last part that we want to add is some type of finish line. So let's have a look at our game world and actually not being 2D. Yeah, so here we are, and we want to have some type of finish line or an area that you need to enter to complete the level. So let's create a Quantum 3D, and we are going to use a static box collider for this as well. Then let's move it into position, just somewhere here, and make it a, or actually we don't need to make it bigger, we can actually keep it fairly small, but we'll make it wider. Something like that. That would be fine. And then let's change our color to red. So, and maybe move it up a little bit. Okay, so maybe it should be taller as well. So this is going to be our finish line, and we want it to be a trigger. So whenever something is hitting it, then we want well, the game to end. So we need to change our quantum code so our player can actually detect this little area and react to it. So let's switch over to Quantum, open Quantum project. And actually let's hide our game session or game state so that we can't change it from the editor in Unity. So let's add this exclude from prototype, and that will make sure that we can't actually change that. And then let's go into our movement system. So in our movement system, we are going to check if the player has reached this point. And as this is a character controller, I actually haven't found any sort of event that we could use. If it would be a regular physics object, then we could actually use events similar to how you do it in Unity. But yeah, I haven't found any for the character controller, but if you do find some, let me know. So since we haven't found anything, we need to use an overlap check. So I'm going to use an overlap sphere for this. And so let's do that. So f.physics3d overlap, and then we need a filter transform position. So wherever we are. And we don't care about the orientation. And then we are going to create a 3D shape. And it's going to be a sphere of size 1. And so that in turn will return a hit collection 3D. So we need to be able to react to that. So let's add it. So hit collection 3D, hits collection. Then we want to check our hit collection and see, okay, what did we hit? So let's do a for loop. So for I equal to 0, I'm smaller than count, hit collection count, and then we'll just iterate through it. And if our hit collection is a trigger, then we are actually have hit the object we want, and then we will change the game state to game over. So this could probably be in our game session state system, but we're going to keep it simple and just have it in here. So let's build that and try it in Unity and see how it works. So let's try it and see what happens. So we have our countdown here. We found our player 5, 4, 3, 2, 1, 0, go. Well, not 0, 1, go. So now I can move the characters. And when I hit this, it's going to say game over. And actually, I think maybe it wasn't size 1. I actually made it into size 1 when we did our cast, but I see here it's actually 0.5. Well, So you can go back and change that, but you get the concept. So now it's game over, we can't move. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. Thanks for watching, and don't forget to like and subscribe. I'll see you in the next video.